Tonight we're solving another LeetCode. We'll pick a medium. Okay, I guess we'll pick another one. Okay. 1759, count number of homogeneous substrings. Okay. Given a string S, return the number of homogeneous substrings of S. Since the answer may be too large, return it modulo. Oh boy, okay. Wow, okay. All right, dynamic programming, right? Wait. Wait, if all the characters of the string are the same. Oh, okay. So essentially we just have to do the counts. And then it's like, okay, so $13. Okay, what are the constraints here? Okay. Let's see if there's 3. Oh man. Okay. So a homogeneous substring are contiguous. Contiguous means they are the same letter adjacent to itself. Okay. You have CCC. I see. Okay. So that's going to give you, like, how many total C counts do we have here? 1, 2, 3, 4, 5, 6. So it's like, what is this? N factorial for number of contiguous. Yeah. Occurrences. Okay. Interestingly, so I'm trying to see if maybe we could do a linear scan. So we pick up an A. So we'll have like a tracker for the length of the current substring. And if, so we'll have a tracker for the length of the current substring and the character. And if the next character is different, then we'll, I guess, reset the counters and we'll increment the total. So what are we returning here? So total count is 0, and then local count, local char, like that. Okay. So at the point where we would break, so 2 factorials, 2, 3, if there were 4, let's just play with this, C, 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 C. So we're going to have, oops, we're expecting, if this is true, 4 times 3 times 2, which equals 24. And we would have 1, 2, 3, 4. Yep, and then we'll have 3 appearances of 2. And then 2 appearances of 3. We also, so it'd be like n factorial plus 1. Let's see, is that true? Because you have 3. Now this is actually 10. Right, you have C, 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 like each as their own. You have C, 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 C. 1, 2, or I guess 3, 6, 10. So it'd be like n minus 1 factorial plus n, right? 3 times 2 plus n, sorry. Let's see if there's 2 of them. N minus 1 factorial is just 1 plus 1. Ugh, how do you do this? I'm trying to look for like what's the kind of constant time way to calculate like what's the formula for the number. Let's see if it's like, oopsies, let's do 2, 3, 4, 5. Like what are we gonna have here? 1, 2, 3, 4, 5. We'll have A, 4, 3. Oh, I see. It's 4 plus, yeah, it should be. I see. So this will be, we're expecting, so this should be what? 5 plus 4 plus 3 plus 2 plus 1. So it should be 15. And here we have, yeah. Okay, so that's the pattern. 5, 4. Yep, so this is 15. Okay, we got the pattern now. So, fair enough. So, it would be... It's also, what is it, length of the substring plus 1. Yeah, all right. I think there's an optimization, but like the, what is it, Gaussian, like when you're adding a bunch of numbers, because like the 5 and the 1 is a 6, the 4 and the 2 is a 6, and then depending if it's like odd or even. All right, we can get to that later. Let's start to work towards a solution, because I think I see the solution here. So max possible equals 10 to the 9th plus 7. And then like we'll just return min max possible total count. Okay, this is just some like boilerplate. We're gonna move this into a doc string at the top. Although it's not in factorial. Okay. So what we want to do is iterate over the string track current char and current length. I will call them local. So yeah, and then we'll do previous char. We will call them cur. Okay, so first let's check if I guess we don't need this current chart because it'd be here. So if it's equal to the previous char, what we'll do is we'll keep the current, or no, we'll update our count. So current count plus equals 1. And the previous character is the same, so we will continue. So at this point, we have a break in the pattern. I shouldn't use the word break because we're in a for loop, but at this point, current char is not equal to prev char, so we need to actually handle this now. And we'll do our kind of calculation. So we'll do handle count update, we'll call it, and then reset counters. Reset the counter. Okay. So at this point, let's see, we'll do, let's break this out just for cleanliness. So total count plus equals self dot we'll do local total for the current count. This will return an int. Return the within this group. So if this was like, I don't know, what was the example? We used 5 of a kind, we'd return 15. So that's our handle count update. I guess we can call it that. So then we reset the counter. So cur count equals 1 and prev char equals, actually, let's see. I think we should always update current count. Yeah. So from the beginning, our count will be like 1 and let's see. So I'm trying to avoid the case where we're first starting out, because this will not be true, even though we will be on the first run of the first character. So like, what's the case where we'd update the previous character? I think always, right? It's safe to do so. So I think we can do it like this. So if the current character is not the previous character, and what we can do. So is it assumed that the length is, yeah. So then what we'll do is prevchar equals s sub 0. Just so this way, for the first character, we will say that it is equal to the previous character, which is what we want, right? So that we don't update the total till the next iteration. We will also, so let's see, we'll do, also need to pull this guy down here. So if the current count is essentially not reset, so if we had a string of all A's, this would never be true, this line 20. So we need to update the count before we actually return. Oopsies, I think we would want to do this at this point. Yep, so we use the current count, reset it, then pop down here. Yep, okay, this looks good, this looks good. we'll walk through this again before we kind of submit it, but at this point, so example, we have 5 in a row should return 15, right? Yep. So and 4 in a row should return 10. So I'm trying to think. It's n plus 1 integer divided by n plus 1 times n integer divided by 2. Does that sound right? So 6 times let's see, for 4 it'd be 5 times 2. Yeah, that's right. All right. How do you handle the odd number case? What is that? I suppose you don't need the integer division, and that would handle it, right? So you had be 6 times 2.5, which would be 3 times 5, which is 15. Okay. Yep, I think this is right. We'll have to check with Mr. Gauss, but yeah, so expectation is that 1 would return 1. So we can write, like, we'll write some pseudo tests. So we'll move these down. Expected, oops, input expected. So 3 should return, let's see, what would that be? 3 plus 2 plus 1 would be 6. Let's just go down the line. 2 should return 2. 4 should return, what do we calculate? Let's see, yeah, 10. And 5 should be 15. So what's 2 times a half is 1. That's correct. 3 times 1 is, wait a second, is 2. No, 2 should be 3, no? Yeah, it's 2 plus 1. This should be 3. So my test was wrong. Because if you had AA, you'd have A, comma, A, AA. 2 and 1. Oops. Okay. 3, you'd have 4 times 2. Wait. No, 4 times 1.5, which is 6. And for 4, you'd have 5 times 2, which is 10. Yep. Okay. So this is correct. Because we already tested. That'd be 6 times 2.5, which is 3 times 5, which is 15. Cool. All right. So, and for 0, let's just make sure this handles the 0 case. Any good tester would have tested 0. This will be 1 times 0 over 2, which is 0. Nice. Okay, very cool. Very cool. So I guess we could do a little optimization. So if total count greater than max possible, return max possible. But it's not, as far as big O is considered, this is not going to change the runtime. But, you know, if it is really true, as they say in the problem, that the answer may be too large, that this is worthwhile. Could save us some processing. So, all right, let's see here. We'll leave this in. So we have total count, and then current and previous, current count, previous character. So these are our local trackers. So then we iterate over the string. We'll take this example. I didn't mean to submit that. My bad. Okay. So the current character would be A. The count would be +1. The previous character is also going to be A, so this is a match. We don't run this. We set the previous character to A. Next iteration, we're going to pick up B. The current count is going to be incorrectly high, because we'll have 2. So, let's see. I see the problem here. Okay. So we should set this to 1, and then we should move this current count update way to the end. So restarting here, what we'll do, we're going to pull current char is going to be A, previous char is going to be A, count is going to be 1. Current char is the same. So we don't do this. You know, this should reset to 0. This was my mistake. Okay. So we'll update previous char, and then the current count is now 1. By the time we read B, current char is B, previous char is going to be A, current count is going to be 1. This is not going to match. We're going to have a count of 1A. We'll update that, then we'll reset the count to 0. We'll set the previous char to B. Current count's going to increment to 1. The next iteration will be at index 2. Current char B, previous char B. Current count is going to be 2. We move on to index 3. We'll have a disparity between the current and previous character. So we'll have a current count of 2. We'll update. We would expect this to return 3. Reset current count to 0. Update previous. Okay, so this should work. Let's just think through the end of the string case. So at this point, the last character in the string so this should handle it. Okay, I'm pretty ready to run this code. Oh, yeah, this should be N. That was sloppy. Wow. Oh, okay. Hopefully these are all right. So we just have to return an int. Nice. Okay. Let's see. Let's run this. I guess I should have looked at that in terms of constraints, but I guess Python here, you know, this should return an int. So really it's this that needs the wrap, but you know, Python does weird things where it will give you a float. Just, I suppose you are using a float under the hood. So this is expected. It's just abstracted. Excuse me? Let's use this test case. Wow. What's the length of this? Golly. Wow. Okay. It's pretty crazy. It's still pasting. It's like what? This one's probably pretty close to that 10 to the 5th. Yeah. I mean, I suppose they're going to give us 10 to the 5th. Oh, I see why. Wait, do I? Let's see. Let's clean this up. Ten to the 9th. Oh wow. Okay. Shouldn't this be 10 to the? Return it modulo. Oh. That'd be where. Maybe where reading the instructions is good. So we'll remove this line. Ten to the 9th. Okay. There we go. Okay. Okay, cool. So looks like we have a decent algorithm here. Yeah. In an interview, I would dock myself points for this just because I didn't catch this stipulation on returning the value mod 10 to the 9th plus 7. But I still caught it, so not the end of the world. All right, let's analyze this algorithm and then sign off here. So essentially we have constant space trackers here because we're not restoring the substring, which in this case 4, if we were to store this entire substring, that's the entire input string. So that'd be n linear space. We're only storing one character and a couple of integers. So this is, for us, constant space. What's cool here is this handle count update is constant time. So that's really nice for us. So that means that all we really have to do that's variable is iterate over the length of s. So that makes this O of n in time complexity and constant space complexity. So quite a fast linear algorithm. Much better than we would do if we tried to do this with dynamic programming. So yeah, that was 1759, count number of homogeneous substrings.